Hello and welcome to the final part of this QED lecture on Hypothesis Test 1. And this will be short on the conclusions. So we started the lecture by looking at a concrete example of a t-test in the beautiful Usambara Mountains in Tanzania. Please try and go there if you've never been in that area. Then we looked at the ideas of sampling and measuring and how if you want to do any tests, they're not going to completely cope with mistakes that come up in measuring. You've got to make sure you haven't got any systematic or random measuring errors. So you have to make sure the data from your sample is correct. And also, sampling, they won't cope with non-random sampling errors. So if your method of getting random sample is no good, don't forget about doing a test. You've got to have a good method. But even if you have a good method, you can eliminate the bias sampling, but you can't eliminate random sampling or random sampling errors. So that's what a test is going to help you do. Tests help you tell the difference between things you're seeing because of random sampling errors and things you're seeing because they really have happened in the population. Then we've moved on to the idea of a universal tester. So the principle here is that you always have something that you believe about the world, which more technically called a null hypothesis. So you believe your null hypothesis until you see something that your null hypothesis means is very unlikely. So if the thing you believe means that the observations are very, very unlikely, then you have to reject the thing you believe. And we applied that to the RCT examples. Then we finally had to dive into the nitty-gritty of it. Okay, that's all very well, but how do you actually work out the probability of these things? And we looked at one particular example, developing from the Z-score through the idea of the central limit theorem, reassuring us that even if the underlying distribution is really uneven and wonky, central limit theorem is going to mean that with a big enough sample, you can still apply the normal distribution ideas. The extra step of not knowing the standard deviation of the population means you have to use the estimated sample standard deviation of your sample, which moves you from a Z distribution into a T distribution and gives you a t-test. And that lets you get some actual p-values, particularly when you're comparing means, which is what the t-test does. So let's look at some conclusions then. Okay, so to conclude, hypothesis tests address random sampling error, not non-random sampling error, not measurement error, random sampling error. They can never give you a definite answer. So in all those things where I paused, gave you multiple choices, the top answer, definitely yes, the bottom answer, definitely no, those are always wrong. But all they give you is that the probability of different possibilities. Possibilities with small p-values are the ones you can reject. If they've got larger p-values, you can't really be sure what to do because both things could be compatible with it. When you get a small p-value, that means the thing that you believe in order to get that p-value, probably that's wrong. The specific example of t-tests, because all this stuff until there applies to any test, when you get onto t-tests, they also need the theory of normal distributions, the central limit theorem that tells you can assume that with a big enough sample it becomes normal, the theory of sampling in other words, and the t-distribution when you estimate the standard deviation. And then a simple t-test compares the mean of a sample with an assumption about the population mean. So for example, the t-test, we've got an assumption that it's still the same as it was in whatever year it was, 1996 or whatever year was it when they did that measurement. So you assume what you're given what it used to be, and then you want to test whether that assumption still holds true now or not. And we'll see later on there are t-tests that do other kinds of things as well. So there'll be some examples of that to work on in the data exercises, and then we'll generalize that onto different forms of tests next week. Questions please in the forums, or bring them to the live discussion session, but for now, thank you for watching.